Lastly, I'd like to talk about integration with respect to parametric equations. And it is possible to do some form of integration with respect to area under a curve. But the thing is, we're talking about areas trapped between a function and the x-axis. When you take away the restriction of passing the vertical line test, you can get a lot of strange things happening, a lot of unexpected things. So you don't necessarily always get the results that you expect in that type of setting. So we really tend to stay away from integrating with, something in the form of area for parametric equations. It seems to make more sense, however, to generally integrate in terms of finding arc length. All right, so if we want to find the arc length of a set of parametric equations, we have a formula just like this, which we actually developed at some point early on in the class when we were talking about arc length of functions. It just simply was a special case of parametric equations. Essentially, you'll see the same construct here. So the arc length of a function is going to be the integral from the starting value to an ending value of the arc of the square root of the derivative of the y component squared plus the derivative of the x component squared dt. So let's try this out with a simple example. So starting with x equals 3t minus 1 and y equals 1 minus 2t. So this would just be a linear function, and so we really could get this arc length using the straight distance between the start and end point. But let's just try and calculate it using this formula and see what happens. So the arc length here would be the integral from our starting point to our ending point of the square root of the derivative of the x component. So the derivative of 3t minus 1 is 3. Oops, sorry, that's going to be squared, but not right away. That's derivative will get squared. And then the derivative of the y component. And, I just realized I have dy dt and then dx dt. Because it's being added, it doesn't really matter. It probably would have been more proper to write the equation with dx first, just to be in alphabetical order. But that's okay. Dx dt, well, now I'm backwards. Now I'm on dy dt. So that would be -2, and that will get squared, and then we'll integrate dt. All right, so the thing about these arc length calculations, it's just like before. We really only have very specialized functions where we can compute the arc length exactly. Most examples, you have to just do some sort of approximation method. So the ones you'll be given, you'll be able to do algebraically, but it really kind of restricts the types you can do. Like for instance, this case, this would be the square root of 9 plus 4, which is 13, which isn't dependent on the variable t. This is just a constant. So really, I'm just taking the square root of 13, and when I do an integral from -1 to 3 dt, essentially I'm just getting, the horizontal distance between those 2 points. So 3 minus -1 would be 3 plus 1, or 4 root 13. And if you're interested, you could determine, based off of plugging in a t value of -1 into the x and y components to get a starting coordinate, and then plug a 3 into these endpoints to get an ending coordinate, and then actually calculate the distance between those 2 points, and you'll find that it results still in 4 root 13. Okay, so let's do a little more interesting example. This is a circle, so we want to find the arc length of a circle, and this is on the interval from 0 to pi, if I was going from 0 to 2 pi, I would be traversing around the entire circle and essentially getting the circumference of the circle. So let's see what happens. Well, this arc length would be the integral from 0 to pi, the integral of dx dt, so the integral of cosine is negative sine, so negative 3 sine t squared, plus the derivative of 3 sine t, which would be 3 cosine t squared, dt. So that becomes the square root of 9 sine squared t plus 9 cosine squared t dt. 0 to pi. 9 is a common factor that can come out, and that would leave me with sine squared t plus cosine squared t. And the nice thing about trig is that Pythagorean identity, which says that the sum of these two add up to 1. So essentially this is just the square root of 9, which is 3. So I'm looking at 3 times the horizontal distance between 0 and pi, which would just be 3 times pi minus 0, or 3 pi.